Hello community, AI 2024, a brand new year, and today I will show you how we can code the truth. So, last time part 1 ended exactly with this slide, and now we move on, and you remember, we now investigate what is the third building block of AI. And here we go. Now, it is simply, first part was here, the pre-training, the fine-tuning, and the DPO alignment of an LLM. Second part was here the prompt engineering, in context learning, everything to do here. And now we are outside of our AI intelligence. And now we build new worlds of AI outside of our main AI. So let's start with this. You know, if you are an expert, you know that there is a particular term that is called Retrieval-Augmented Generation system. But of course, this term is so much 2023 because right now we have to call it a retrieval system of autonomous self-coding, self-correcting, multi-AI, multi-agent, complex hyper-AI systems, just to be correct. And here we jump in. And finally, may I say really finally, we have an expression language, LCEL. Now, if we look here at the marketing material here, I think it's amazing because it was designed from day one to support putting your prototype, so your AI prototype, directly in production with no code changes. And I think this is a statement, wow, we have to celebrate this company for finally achieving here an expression language. So day one, you have a prototype and you put it in production. And boy, are you gonna be surprised what happens if you really do this. So maybe you are a little bit more careful also. This could be an interesting development. Why? Without LCEL, we had this old-fashioned whatever this was, and now it's a little bit more streamlined, and we have some nice parallelization happening here with this further optimization. So if you missed out in 2023 on this, never mind. You can cross it out now today because we have something brand new, and now you just have to learn an expression language. And simplest case, you query a SQL database. Now, I know you might say, hey, even without any of those, I just can make an API call and GPT-4 knows how to do a SQL call to a SQL database and I get my result back. Yes, but would you have the chance to code this? Huh? Yeah, now you see the benefit. Since we are focusing here on the external world here of RAG and the beauty of RAG, we can make it grow and combine and make here extreme meta RAG. There is a beautiful code. So look what we can activate. Some prompt tablet, some chat OpenAI, some embedding, some output parsers, some runnable lambda, some pass-through runnable objects. My goodness, isn't this fascinating? And then you can ask the question, hey, Harrison worked at a specific company. And then you say, hey, answer the question, where is Harrison working? And all of this complexity will work to find a solution for you. Of course, you know, here, expression language cookbook, and then there's a chapter about agents. And you know, we love agents. Agents are beautiful. Agents are AI systems. And we can build an agent here from a runnable just by doing data processing, the prompt, the model, and an output parser, and we just have a little bit of code, and then you can ask here the system, hey, what's the weather in New York? And I know you can do this also without any of this. But isn't this much more beautiful if you have all this code available for you? Huh? So, let's say, practical example. I have my question to GPT-4. Hey, what are the emerging trends in renewable energy technologies and how they compare to traditional energy sources in terms of investment and efficiency over the last 5 years, starting today at January the 5th, 2024? Now, GPT-4 has no idea about January the 5th, 2024. Therefore, it has to go outside. And outside, you can build beautiful worlds of multi-AI system, databases, queries, connection to the internet, and your credit card is gonna scream in enjoyment because there will be so many calls to your credit card. So at first, of course, here with LCEL, the runnable parallel objects will identify the components, emerging trends, traditional energy sources, investment comparison, efficiency, comparison. And then you have a parallel execution where your credit card is screaming in enjoyment and says, yeah, finally I can connect here to a renewable energy database for the latest technology and the trends. I can connect to multiple financial databases for the investment data, both in the renewable and the traditional energy sectors. And I have then studies. I can go to Archive. I can go to my scientific university databases for performance data for the latest research. And then you bring back all the data. You do the cleaning of the data. You do the formatting of the data, all the complete pre-processing. You use here Python programs like scikit-learn, or maybe you use some machine learning algorithm for pattern recognition, trend analysis, whatever you find. And I know you could do this in Python, but look, this is a language you can do this. And then, of course, it goes on. You have now some external AI system, so outside of GPT-4, that are performing now specific trend analysis in Python for investment patterns, or finally you bring all of this together. So you do this normally outside, you pay for a cheaper LLM like a ChatGPT or a Claude system, and now you create a more readable narrative style response. And then finally, all these chains come together, all condense, all this multi-step process with asynchronous and parallel execution capabilities are now compacted together, and you can, for example, create a prompt that you can insert into GPT-4, and GPT-4 will generate a beautiful answer for you. If you think that this is a little bit over the top, over-designed systems we call this, where you have a primary GPT-4 system, a secondary GPT-4 system, a secondary ChatGPT system, some machine learning algorithms, some scikit Python code, some MySQL or NoSQL databases, or external AI systems like Claude, or some normal databases, relational databases, some connections to the internet, and you mix all of this here in an autonomous sequence generating code, and you say, yes, I need this outside because I did in my GPT-4 pre-training some special pre-training on some really complex financial patterns. And now I need an extreme complementary financial pattern here for this specific problem, because this specific GPT-4 system has been pre-trained in a very particular way for my specific company needs. Then maybe you would need one additional AI outside. But I have seen construct with 17 AI systems interchained, and I think this is an over-designed system. So if you are a CEO of a company and you are confronted with the idea of an AI integration, and some companies bring you an idea with 17 external AI systems that run outside of your primary, let's say, GPT-5 system, in summer of 2024, think about it twice. Beautiful. Now, since I said this is a video about how to code the truth, there is another uncomforting truth. I've seen companies that have multiple databases in their company, and those databases lack interactivity or coherence. For example, if you have a database on CRM, you have your finance database, you have your finance reporting database, you have your human resource database, and you have your investment database. And you fail today that those databases are in sync, and you hope that AI will provide the solution that you do not have a redesignment of your complete financial reporting system in your company. Let me tell you, the chances that you get this right with an AI system are minimal. So do not think that AI is the solution to everything in your company. Sometimes it might be better first to do here a reset up of your internal reporting. I don't know, SAP might be a solution. Some open source SAP alike might be a solution. So at first, think about what you absolutely need, then optimize here, for example, the financial reporting, and then think about maybe you need only, or maybe you need nothing at all for your AI integration. So careful. I know some companies sell their solution as a solution for everything that happened in the past, but unfortunately, it turns out maybe they're just in the marketing. So, yeah, of course, we're talking about money, we're talking about investment. A lot of investment companies invested in startups in 2023, and I already told you, new startups focus on vector store. They invested tens of millions and hundreds of millions of dollars globally in vector store startup companies. And now those companies have to generate at least billions of revenues for their investors because they want to have an investment, a return on investment of at least 10. Therefore, you see a lot of commercials out there. Use this vector store. No, this vector store is the best. No, we have the best vector store. Think about if you need a vector store at all, and then please go and choose wisely. Talking about vector store, talking about vector embedding, talking about vector spaces that we construct in a high-dimensional mathematical space, we need an AI system to create this from our document server. And of course, we do here the similarity research, the similarity search operation here by semantic similarity. And our LCEL also invites us here in a cookbook to do the routing by semantic similarity. So for example, you import something, you have no idea what it is. And they say, hey, you are a smart physics professor or you are a smart mathematician professor. And you can choose between physics or mathematics. Congratulations. And then you have the embeddings. You can buy the embeddings for this particular problem from OpenAI. Or buy the embeddings here. I don't know, from Cohere. Cohere would be a good solution for embeddings. You have your prompt templates, you have then your embeddings of your document, you have the embeddings of your query because you have a specific query that you want to answer. Like the query is, what is a black hole? So you put everything in a vector space, everything is transferred to a vector, and then you just look here at an epsilon environment of a particular vector endpoint in your vector space. And you have here the cosine similarity function with the maximum, the 5 maximum contenders that are real close by here in this mathematical vector space. And those 5 qualify here for an answer. And you can code this in LCEL and you say, my goodness, I'm so happy I can finally do this. I was asked by my viewers, can you show me RAG? Yes, of course. Here, everything outside of GPT-4, your, Mistral 7B or whatever you have, whatever you retrieve on external data outside is a retriever, is the R. The retrieved data are cleared, financed, compressed, put together, cleaned up again, polish the data, and then you bring the data here to augment here the data with real-time data from the internet or from some databases. You have an augmented information you provide now in the input to your AI system. And this AI system here is the generator and now generates an answer. RAG. Beautiful. Yeah, I got a question. ICL versus RAG. Isn't it, in theory, in its routing functionality, the same? Yes, of course. Hello, RAG community. I'm looking forward to your comments. So, here from a RAG textbook, in summary, while the maximum context length applies to both, of our input tokens, to both the ICL in context learning and retrieval augmented generation, when using models like GPT-4, RAG potentially offers more efficient use of this context space. So if we have a context length of 8K or 32K or 34K or 64K or whatever, the RAG textbook tells us, yeah, but RAG is better, no? And the efficiency is achieved through a dynamical retrieve, an automatic retrieval, and a pre-processing of external data. I mean, no wonder you have multiple AI systems, multiple scikit-learn Python functionalities outside, and then allowing RAG to potentially include more relevant information within the same token constraints. So, you remember here the maximum length here for our token is valid for ICL and valid for RAG, but our textbook tells us, yeah, but RAG is much more beautiful and does it much more efficient because it includes more relevant information. The information is more compressed and compacted so the information density is higher, although the same token constraints apply to both models. Now, talking about the history of 2023, at the very beginning we started here with a naive RAG. So this is really where we had no idea what it is, so we had a query. We asked GPT-4, and GPT-4 said, hey buddy, I have no idea. Look up the document server, do a vector database embedding here of all the semantic information in the documents. Then we have here a cosine similarity search, and then we find here the nearest close by neighbors. And this close by neighbors have here some additional information I provide in the prompt. And then this augmented prompt we will feed into our LLM, our GPT-4, and then we have the perfect answer. This was the naive. Now in summer of 2023, we went to the advanced RAG system. It is the same, but we have a pre-retrieval and a post-retrieval optimization. Pre-retrieval is simple. Post-retrieval is nice. Now, some people think that the re-ranking was invented here in summer of 2023 for our advanced RAG system. I'm so sorry. And as a proof, I have here my Esper 28 video from 2.5 years ago, I think about. And here with the cross-encoder, I showed you the first re-ranking with cross-encoder here for the advanced semantic search in sentence transformer. So they just used here what we know, that the bits and pieces that we already discovered, and put it here in a new configuration. And yes, re-ranking helped here to achieve some additional performance points. You could filter, or you use some prompt compression. Prompt compression now is really quite new. Simply you ask GPT-4, hey, GPT-4, I give you this prompt with 1000 tokens. Can you compress this so that I have the same level of information, but only in a content of 800 token, and GPT-4 will perform this task for you. So you have now the post-retrieval optimization, and we have advanced RAG system. Isn't this beautiful? And then 2024, we look here at the complete intellectual potential, what happened, and now we have Modular RAG. And you say, amazing! Let's jump to the most complicated self-RAG. So we have a system that decides, on demand, retrieves additional information, generates here in a self-reflective way, criticizes its own finding, its own decision, and lets the process start all over again. This is self-RAG in 1 minute, but of course I have a video for you, self-RAG AI, explained in detail in 40 minutes, and I give you here a complete understanding what self-RAG is all about. Beautiful. This is a link to a scientific publication. You have here the archive link here in the lower right corner, where they show you now all the different models that have been developed in 2023. Now, RAG, you know, here the retriever, so our R is here, our generator G is here, and now you see here for better semantic representation, you had the chunk optimization or to fine-tuned embedding model, and here the corresponding models with the corresponding authors. So if you want to have a deep dive into one specific re-ranking, for example, you see those are the models and those are the authors you should look up if you want to improve their work. Of course, what is missing in RAG was the A for the augmentation methodologies. And here you have the stage, the data, and the process itself. And you see, yes, my goodness, we have now combinations that are amazing, from pre-training, fine-tuning, inference, structured, unstructured, semi-structured, synthetic data, whatever you can imagine. Let's look at the most complicated adaptive retrieval. You have here again the self-RAG, so you know this is what happened in 2023 on RAG. If you find a project or hear some idea, you can identify here exactly what methodology it uses, and it gives you an idea in which environment it lives on the RAG ecosystem. Please note that be careful if you decide to start an investment in a RAG system for your company from the ground up, because, as I've shown you in these two videos, Salesforce has done this for you. they already invested tens of millions, hundreds of millions US dollars for their commercial business-to-business service. Where, for example, their GPT is Einstein GPT, and they have focus here on CRM, sales, service, support, quality, and they have this optimized already now for months. Or if you go financial reporting, SAP in your company, they have their Joule is here SAP's new generative AI assistant. It connects human resource to finance, to supply chain, to procurement, to customer experience. So you have an AI that has been pre-trained on all SAP data. I hope so. I think so. I don't know. Maybe it's just 90% of all global SAP data or whatever. So might be worth a look before you have your start investments. Maybe you can go with one of the solutions that are already for you available in a business-to-business environment. And here for the future of shopping, I showed you how Amazon has now a future implementation where they also do this here on their AWS Titan AI multi-AI system. Beautiful. Yeah, if you really want to have a deep dive what comes after RAG, of course, it's going to be a multi-dimensional path model. This is the video for you. And here, finally, we come to the age-old question. And everybody asks himself, hey, what is better? Should I have my RAG system? Or should I fine-tune simply my GPT-4 or Mistral 7B system? And here from this publication, I think they have a very nice comparison of each different feature, and they show you here either, this is the benefit of a RAG system, and this is the benefit of just fine-tuning, which can be significantly cheaper than you build RAG system, or it can be the other way around. You can have a very simple RAG system, a lot of open source, costs you hardly anything, and this is then much cheaper than fine-tuning of GPT-4 systems. So it really depends on your business case and what you want to achieve. So choose what is important for you. Check it out, and then you know you should RAG it or you should fine-tune your large language model. To give you an in-depth review, I have here two videos of two different approaches. This is the RAG approach, and this here is the fine-tuning approach. Microsoft gives you here an idea, doing the prompt engineering pro with vector databases in a clinical context. They have MedPrompt, where all the actual information is updated only in the vector store, and then the vector store does some RAG optimization for an LLM and is fed into the LLM. And here, contrary here, Google shows you here from the research laboratories here, its future way where we have a continuous, I don't know, every night, every weeknight, every weekend, a continuous fine-tuning of new data coming in, being fine-tuned of the model, so they are inherent part of the model. However, here, you know, with the prompt, the moment we reach here the critical length of the context length of the prompt, all the knowledge is forgotten by the system because the tensor weights are not learned here of our LLM. Contrary to here, this system continuously learns. The title is New AI Agent Self-Improvement and Self-Fine-Tuning. Whatever will become available in the future, whatever will dominate in one or other industrial sector, time will show us. But please note, you do not have to rely on NVIDIA GPUs. I think they have not enough VRAM available at all for a normal price point. So maybe it is a good idea also for a company, have a look. Apple has now a new machine learning MLX framework, and they have some beautiful models running over there, you know, and Apple infrastructure and M1, M2, or M3 laptop with up to 192 gigabytes of unified memory. This means CPU and GPU memory, 192 gigabytes is plentiful for AI application if you do not have really time-critical jobs. But this is now a comparison of two completely different approaches. And yes, neither sponsored nor promoted nor somehow anything anyway. I just think Apple is here really providing an opportunity for the infrastructure platform. Great. So there you have it. AI 2024, what I think you should know if you start to code here, the truth about coding, also how you can code here the truth itself. Sometimes you do not have to reinvent the wheel. You do not have to reinvent RAG-specific systems. There are a lot of opportunities out there to go and pick one RAG system from the shelf, or you go to your service provider, SAP, or any other provider you already work with. There's a high chance that they already have a very optimized system available for their customers. Go out, compare, be critical. I always ask 100 questions more, but I think, or I hope that this video helped you a little bit to discover the truth how AI in 2024 will go on and where the status quo is. Hope to see you in my next video.